Hello, we're going to go over worksheet 4.3, Vesper angle and geometry. What I would like to have when I do this is my angle and shape chart, and I definitely will also need a periodic table. So we'll start with HF. So the assignment says draw the Lewis structure for these, and then we will work our way to the angle and the shape. So HF. H has one valence electron, so it has one dot. Fluorine, I look on a periodic table, and fluorine is in group 7, so it has 7 dots. 1, 2, 3, 4, 5, 6, 7. Looks like those will be a shared pair, so we'll draw H with a line and then an F, and we will still keep those dots on there. So that's essentially what that Lewis dot diagram looks like. But let's double check and make sure the H has 2 electrons, 2 because H is perfect at 2. And then we'll look at the fluorine. I didn't get those ones down there on the bottom very well. Fluorine should have 8 because it wants to achieve an octet. So 2, 4, 6, and then 8. So they're good. So number of charge centers around the central atom. There is no central atom, so that is not applicable. The next question is number of lone pairs on the central atom. There is no center, so not applicable. And the next one is atoms attached to the center atom. There is no center, so that's not applicable. So what is the angle and the shape of this compound? And we go to our little chart, and the only thing on here that seems to have not applicable would be linear, so 180 degrees. So it's going to be 180 degrees, and it's going to be linear. And if you look at it, it makes sense that that is what it's going to be. If you have 2 atoms, the furthest apart they can be is 180 degrees. Number 2 is CO2. The single atom is the one that goes in the center, so we'll put carbon there, and then we'll put an oxygen on either side. And if we look at our periodic table, carbon is in the 4th row, so it has 4 dots, and then each oxygen is in the 6th column, so they will each have 6 dots. So let's draw our dots. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And now we're going to see how we could share these to achieve an octet. So I think those 2 will share, and those 2 will share. And it looks like those 2 will share, and then those 2 will share. So it looks like we have double bonds on both sides of the carbon. And then the oxygen, don't forget those electrons that are still not bonding, those non-bonding electrons. They're called lone pair electrons. And let's check and make sure everyone has an octet. 2, 4, 6, 8. 2, 4, 6, 8. And then we'll look at this other oxygen. 2, 4, 6, 8. Struggling with my math there. So the next question is the number of charge centers around the central atom. So carbon is the central atom, so the number of things around it are 2. And the second question, number of lone pairs on the central atom, that is not, I shouldn't say not applicable, it's 0. There are 0 lone pairs on that carbon because that carbon is sharing bonds, so there aren't any that aren't paired up. The next one is atoms attached to the center atom, and there are 2 atoms attached to the center atom. And I like to go 2 plus 0 equals 2, or 2 equals 0 plus 2. And I go to my chart, and I find something that might have like a 0 and a 2 on it. And let's see here. Aha, it's this linear one again. So 0 lone pairs on the center, but 2 atoms attached, 180 and linear. So 180 degrees, and it's going to be linear. question number 3 is BCl3. Now B is going to reach its perfection at 6, not the octet, and chlorine will reach an octet. So boron is one of the exceptions. Let's turn the light on. There we go. And so our diagram, the single one goes in the center. I'm going to do a little preliminary work, I think, over here. I'm going to put B in the center. B will have 3 around it, and then we have 3 chlorines. We'll put 1, 2, and 3, and each chlorine will have 7 dots. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and a 7. And those pairs will find each other, and so you'll have a boron with a chlorine, and a chlorine, and then don't forget those other dots that are not bonding around the chlorine. And then boron is finished because it has 6, the 2, 4, 6, and each chlorine is finished because it has 8, 2, 4, 6, 8. So next question, the number of charge centers around the central atom. There's 3 things happening on the center, 1, 2, 3 items. Lone pairs on the center is 0. Number of atoms attached to the center atom is 3, and we'll go to our sheet and we'll find the 303. And I think the 303 is 120 degrees trigonal planar. So 120 degrees, and I'm just going to call it trig planar. It's in the same plane as the paper. Now let's go to number 4 is water. The oxygen is the one in the middle. Those hydrogens will be on either side. Each hydrogen has 1 dot. The oxygen has 1, 2, 3, 4, 5, 6. We'll have some sharing there, but then we'll have those lone pair electrons. And hydrogen is perfect at 2, and that's why it is good with just 1 line, because that'll add up to 2. And then we say number of charge centers around the central atom. There are 2, no, there's not 2. There's 1, 2, 3, 4. There's 4 charge centers around the center, and the number of lone pairs on the center, there's 1, 2 pairs. I know there's 4 electrons, but we always count them in pairs. And the number of atoms attached to the center atom is just 2, those 2 hydrogens, 1 and a 2. So the angle, so we have, notice this, a 2 plus a 2 equals a 4. So we'll find the 2, 2, 4. And that looks like it is at the very bottom of this paper, the 4 and the 2 and the 2. And it says 106 degrees, and it is bent. So we'll say 106 degrees, and we'll call it bent. And it's called bent. If you look at this picture, there's a hydrogen, there's the oxygen, there's a hydrogen. For these all to exist within that 3D shape, they are about 106 degrees apart, and it makes them bent, actually. The next one, H2S. The S is in the middle. S has 1, 2, 3, 4, 5, 6. Each hydrogen, again, has 1 dot. So it's a lot like water. In fact, you know it's like water because the S is in the same column as the O. Sometimes that's my trick for making test questions, like maybe on a worksheet, I'll give you H2O, but on the test I'll ask you H2S, so it's really the same because it's in the same column. So we get sharing between those 2. So H a line, S a line, and then those dots are still there. And then we'll ask ourselves the next question, number of charge centers around the S. There's 4. 1, 2, 3, 4. The next question is lone pairs. There's 2 pairs. And how many atoms? There's 2 atoms, so it's the exact same as that water. So it is going to be 106 and bent also. 106 degrees, and it's bent. I like to say it's bent out of shape. The next one, CH4, the C goes in the middle, and the C has 4 valence electrons, and then each H has 1 valence electron. Squeezy wheezy. Oh man, I'm going to have to squeeze that H in there. And so they share. I'm probably going to have to draw this a little bit smaller. H is satisfied with just 2, so it just needs a single line, and then the carbon adds up to 82468. And the number of charge centers around the center, there's 4 things attached to the center. The number of lone pairs on the center, there are no lone pairs. And the number of atoms attached to the center is 4. Notice that 0 plus 4 equals 4. And the angle and the shape, let's go to our sheet and find the 404. This sounds like a freeway, doesn't it? The 404 is 110 tetrahedral. Ooh, I love the tetrahedron. So 110 degrees, and it's a tetra. I should show you what I'm doing. Tetrahedral. So it's a tetrahedron. Let's move on to number 7. It's NH3. In the middle is going to be N. And N is in the 5th column, so it has 1, 2, 3, 4, 5, and then we'll have 3 H's. I'm going to squeeze this H in there and that one there. We'll put little doodle dots. So you'll really have an N connected to one H, another H. I'm going to put it on the bottom, another H, and then what we will have left over are 2 dots, but we put those together. Those are the little Gary snail eyes from SpongeBob SquarePants. So the number of charge centers on the center atom, 1, 2, 3, and 4. The number of lone pairs on the center is just 1 lone pair, so we count it as a pair. There's just 1 thing on there that's a lone pair. And the number of atoms attached to the center, there's 3, because those 3 H's. And so we look on our paper for the 413. And the 413 is 108 degrees, and it's trigonal pyramidal. What did we say? 108 degrees. Wouldn't that be a nice temperature? Actually, I think we might be melting. And it's trigonal. I'm just going to write trig pyramidal. Meaning pyramid. It's a little bit pyramid shaped. The last one, number 8, is CH2F2. This one's a little bit of a stinker. So we're going to have the C in the center, but it looks like we have 2 H's, so I'm going to put an H and an H. And I know the H has 1 dot, the C has 1 dot on each side. And then the fluorines, I'm going to put the fluorines on the top and the bottom. And those fluorines have 1 unpaired electron that they'll share with the carbon. And so it looks a little bit like that. Don't know if that's the most perfect thing ever. Close. And so we ask how many things on the center, and there's 1, 2, 3, 4. There's 4 charge centers. How many lone pairs on the center? That would be zilch. How many atoms attached to the center? And that is 4. And then we look at our sheet for the 404. Again, that sounds like a freeway. 404, 110 in tetrahedral. Oh, we did that one, didn't we? 110 degrees and it's tetrahedral. So I hope this helped you, and I wish you luck, and I'll see you soon.